Okay, question 7. Define the following terms. Most of them you can look up on your own, and I do expect you to. But I do want to talk a little bit about the difference between a polar bond and a nonpolar bond. So here's a polar bond. If you can imagine a great big polar bear and a teeny tiny little penguin trying to share a fish. Who's going to eat more of the fish? Right, the great big polar bear, because he's stronger. It works the same way with elements. If you have chlorine, which is very electronegative, sharing a pair of electrons with hydrogen, chlorine will have those electrons more of the time. And since electrons are negative, chlorine will get a negative charge and hydrogen will get a positive charge. That's what we call a polar molecule. Another way you can get a polar molecule is when you have something like water. Remember, water has these two lone pairs of electrons. What do we know about electrons? Electrons have a negative charge, which means the other end of the water would have a positive charge. Now, if we want to talk about a nonpolar molecule, this doesn't happen. In a nonpolar molecule, the sharing is equal. So a nonpolar molecule would be like two penguins of the exact same size and exact same niceness sharing a fish. They each get equal amounts. Or two of the same atom, such as chlorine and chlorine, sharing some electrons. They're both the same, so they share it the same, and there's no charge on it. Rest of them, look them up. So let's draw some Lewis structures. If we talk about sodium chloride, sodium has 1 electron, chlorine has 1, 2, 3, 4, 5, 6, 7. In this one, sodium gives its electron to chlorine, showing that sodium has a positive charge, chlorine has a negative charge, and they stick together. Opposites attract. If you have water, we start out figuring out how many total valence electrons it has. Hydrogen comes with 1, 2 times 1 is 2. Oxygen comes with 6, so we have a total of 8. Oxygen is going to go in the middle, and we're going to connect it to the 2 hydrogens. We've used up 2 4 electrons. Here's 6. Here's 8. Notice in this one, we have covalent bonding, or sharing. When it comes to geometry, we have 2 bonds and 2 lone pairs. So it's going to be the shape of a tetrahedron, except for 2 of them are going to be invisible. So all you will see is a bent molecule. Now, is it polar or nonpolar? It has lone pairs. Since it has lone pairs, it has electrons. Since electrons are negative, it is definitely a polar molecule.